T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
After 25 years of flight, Voyager 1 has flown by Jupiter and Saturn, and then has left the planetary system in a northerly path. It is now about 7 billion miles away from Earth, and it is the most distant human-made object ever launched from Earth. Voyager 2 has flown by the same two planets, but in addition, it flew by Uranus and Neptune, and then flew in a southerly path away from the planets. It is now about 5 billion miles away. Traveling at the speed of light, it takes about 12 hours for a radio signal to leave Earth and reach Voyager 1, and it takes a little bit shorter time, about 9.5 hours to reach Voyager 2. After 25 years, the Voyagers are traveling in a region of space that no spacecraft have gone before, and they're still collecting data that defines the influence of the solar wind far from the sun. We have basically two sets of goals. One is to characterize the bubble, the heliosphere that's created by the solar wind and the opposing interstellar winds. We're looking at the structure of the solar wind. We're looking at the structure of particles and shock waves as they propagate out to those far distances. And the second objective is, if we're lucky, we will cross into the region called the heliopause, which is where interstellar winds exist only. There's no influence from the solar wind. With the spacecraft being so distant, there are some operational concerns, primarily in the amount of time we have to respond to emergencies. So the first thing we do is make sure we don't create any by being very careful in what we send to the spacecraft. And the second thing we do is to have already loaded on board the spacecraft a set of commands that will take care of the emergencies that we can anticipate. We're in contact with both spacecraft on a daily basis, about 8 to 10 hours per day, and we are receiving from the spacecraft both health and status data and the science data, primarily plasma waves and particles information. The Voyager spacecraft can last until about 2020. That's the year 2020. The primary limitation is electrical power. There is no problem with receiving the signals. Hopefully by the time we run out of power, we will have crossed into the area where true interstellar winds exist. It's called the heliopause. The spacecraft carries on board if you will, an interstellar outreach program. It's the golden phonograph record that was assembled by Carl Sagan and company. It has on it pictures from Earth, sounds of Earth, greetings from in various languages, and also greetings from the Director General of the UN at the time the spacecraft were launched, and President Carter.
T-minus 10, 9, 8.
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go.
The two spacecraft were launched in August and September of 1977 on their way to Jupiter and Saturn. And these were the most sophisticated spacecraft the laboratory had ever built, that had ever been launched deep into space, computer-controlled spacecraft. And because they were so smart, it took a lot of time to learn how to fly these spacecraft. So initially, for the first 6 months, we were constantly trying to catch up in our learning how to fly these spacecraft safely. Fortunately, we managed to do that and had very successful Jupiter encounters in 1979. Perhaps the most important discovery in the sense of setting the tone for the whole mission was the discovery of the volcanoes on Io. As we approached Io, we saw an object that looked unlike anything we'd ever seen before. In fact, we have not seen anything like it since. And we did not understand what we were looking at all. It was so different than anything we had imagined. And it was only as we were flying by Io that a navigation image was taken, that is, an image taken with a deep exposure to find the stars in the background, that a navigation engineer, Linda Morabito, noticed that there was this large plume off the limb of this little moon of Jupiter. And that was the first indication that this is the most volcanically active body in the solar system. 100 times more volcanic activity than Earth, and yet it's just a small moon orbiting this giant planet. It was so unexpected that we would find such incredible volcanic activity that it told us that we were on a mission of discovery, that even though we were planning and thinking about what we would see, that we were bound to be surprised at each stop along the way. On to Saturn, 10 times farther from the Sun than the Earth is, colder yet, and what we found were ring systems which were quite dynamic, with many features, rather than just broad rings, some very narrow rings, shepherded by small moons, 2 moons sharing the same orbit around Saturn. We saw what had been moons of Saturn which had broken up and formed this magnificent ring system which can be seen from Earth in much lower detail. So we swung by Saturn with Voyager 2. It headed us toward Uranus, twice as far again from the Sun as Saturn, 20 times as far as the Earth. We flew very close to one of the small moons of Uranus and found a body whose surface was the most had been the most active surface that we have seen in the sense of geologic activity. It's no longer active. It's not like Io, but its surface, even though it's a very tiny world, only about 300 miles across, has cliffs tens of miles high, has large regions which have been geologically disrupted perhaps billions of years ago. Perhaps an indication of the violent birth of that moon and its destruction and recreation in the early phases of formation. We flew by Uranus and headed on to Neptune. Neptune is 30 times as far from the Sun as the Earth. The sunlight there is almost little more than 1/1000th of what it is here at Earth. Very cold, very remote edge of the solar system. And then we flew by Neptune's moon Triton, which is the coldest body we've flown past in the solar system. So cold that the nitrogen, which makes up most of the atmosphere on Earth, is frozen solid as an polar ice cap on this world. And even at that low temperature, we found activity, geysers, spewing material miles up above the surface of this world, which is a captured moon of Neptune. Both Voyager spacecraft are headed out of the solar system toward interstellar space. The Sun creates a bubble around itself. The solar wind, which is a 1,000,000-mile-per-hour wind, creates a bubble called the heliosphere. We don't know exactly how large the heliosphere is. Today, Voyager is 85 times further from the Sun than the Earth is, and may be beginning to approach the interface of this bubble with interstellar wind, which is just beyond. We hope that these two spacecraft will be the first to leave the heliosphere and enter into interstellar space while they're still operating, so we can, for the first time, directly observe what is out and beyond our own solar system. Voyager had that sense of exploration, of going where no one has gone before. And I think there's a real appeal to learning something new, going somewhere and especially when you go somewhere and see something which is different than where you came from. I think that's what Voyager was about. We all hoped that this mission would last a very long time. We have a power supply which will carry us for another 20 years. and we had hoped that there would be no fatal flaws in the spacecraft which would terminate the mission early. Fortunately, although we've had some failures on the spacecraft, our redundant systems, our backup systems have been in place, and after 25 years, the spacecraft are still going strong.